Hello and welcome to Chapter 6 Quiz Review for Algebra 2. So let's get into it. First one, tell whether it's growth or decay. So the first thing I look at is whether it's an E or not. This is clearly not an E. So if this number is between 0 and 1, that is a decay function. Here, not an E, but it's bigger than 1, so therefore that has to be a growth function. However, for 3 and 4, they are E's, so they follow different rules. Remember, when we have E to the Rx, I look at R. Is R greater than 0? AKA, is that 3 bigger than 0? Yes, so it's a growth function. And here, my R would be less than 0, so that is a decay function. So if there's an E, I look at the exponent. If there's not an E, I look at what has the exponent. Okay, graph it using at least 3 exact points. Graph and label the asymptote, state the domain and range. So let's type this right into our graph. We have 3 to the power of x minus 5. Graph. Now, if you remember, this would normally have an asymptote at y equals 0. I know it's a y equals because it's an exponential function. However, this minus 5 is bringing the entire graph down 5. So I know 1, 2, 3, 4, 5 that the asymptote is actually right here at y equals negative 5. I can even see that because if I go into my table, eventually I get negative 5 for all the y values because it's getting infinitely close to that asymptote but never technically there. It just runs out of spaces to do 0.99999, etc. Okay, I need 3 coordinates, of course. So here are some good ones: 0, negative 4. 1, negative 2, and 2, 4. Okay, so this is an exponential, so I know that my range is limited because that's my asymptote right there, that negative 5, and it goes up, so to infinity, and my domain would be, all real numbers. So you could either do that or the double R. Here, I have a log base function, so I know my asymptote is going to be x equals, so let's take a look at how that looks. So remember, if I want to change the base, I'm going to go to math and then down to a for log base 2 of x plus 4. X plus 4, x plus 4. Graph. Normally it's at this 0 line, but I have this plus 4 that's going to shift everything to the left 4. So 1, 2, 3, 4. My asymptote is going to be right here at x equals negative 4. So I'm going to need some coordinates, of course. So some good ones. And you can see negative 4 is the first place where an error occurs. So some coordinates: negative 3, 0, negative 2, 1, 0, 2. And of course, I'm getting that. Now, the graph looks like it stops there. You need to remember that it technically goes down forever. Now, what's my asymptote? My asymptote is an x value, so that's a restriction in the domain. So my domain is going to be that value, negative 4 to infinity. Or my range, I can go up and down forever, so that's going to be my all real numbers. Simplify each expression. I'm multiplying with the same base, so I'm going to add the exponents. So I get e to the 15. Here I'm dividing, 18 divided by 2 is 9, and here I would subtract the exponents. So I get e to the 5th. Here I'm separated by parentheses, so the 4 is going to go to both places and get multiplied. So I get 3 to the 4th and e to the 2x times 4. So I'm going to get e to the 8x. You could type 3 to the 4th in your calculator and get 81. So I get 81 e to the 8x. Okay. Rewrite the expression. So remember, I spiral it. So if I'm starting with a log, I start with the base number. So 3 to the power of 6 equals 729. And again, I can double check that because that's a nice thing. I could type in my calculator 3 to the power of 6, and that tells me that those are equal values. Same thing over here. I can spiral it, but I started with this 7. So I'm going to get log base 7. Next number I got to, 2401. And then that whole thing equals 4. And again, I can type log base 7. So math down to A, log base 7 of 2401, and I should get 4, which I do. So I can always double check that. Evaluate, that just means I'm going to type it right into my calculator. I'm going to round my answer to 3 decimal places. So I'm going to type log of 30 right away. Log 30. So we get 1.477. Okay. Natural log of 2.5. So ln. So ln 2.5. 0.916. And then log base 3 of 81. So I have to go in and change the log base because there's a number there. I should get 4, I believe. Yeah. Okay. Next slide. You purchased a baseball card for $5 when you were 10 years old. The value has increased by 6% each year. Write an exponential model that gives you the value of the card in T years after you purchased it. So the formula we're going to use is y equals a parentheses 1 plus r to the power of t, where a is my start, t is my years, and R is my rate, but I have to convert it into a decimal. So how much did I buy for it originally at the start? $5. So that's going to be my A. The value of the card increased by 6% each year. That's going to be my R. So plugging those in, we get Y equals 5, 1 plus 0.06, because you have to convert this into a decimal by moving the decimal place over 2 spaces, 1, 2, so 0.06 to the power of t. Technically, we can add those together, so we're going to get y equals 5, 1.06 to the power of t. And then it says, how much is it worth 20 years if you purchase it? So we're going to plug in 20 in for T. And it says, round your answer to the nearest full dollar. So 5 times 1.06 to the power of 20, right into our calculator. So now, nearest dollar would be 16. So I would say $16. Okay. Find the value of $3,000 deposited 8 years in account paying 5 annual interest compounded weekly. Whenever you see a compounded thing, you have to use a slightly more complicated formula. In this case, it says compounded weekly. So I have to use the formula y equals p 1 plus r over n to the power of nt. Now, p is still my start, this number in front. So this is going to be my 3,000. T is still years. That's going to be right there. And R is still interest rate. So R is going to be 0.05 because you have to move the decimal place two places. The only difference is now I have compounded weekly. N is times per year. Well, how many weeks are in the year? That would be 52. So N has to be 52 there. So we get 3,000. 1 plus 0.05 over 52 to the power of 52 times 8. And I could type all that right into my calculator. And we get about $4,474.61. It's money, so two decimal places makes the most sense for me too. Okay. This next one says compounded continuously, so that's a third formula. Anytime you see compounded continuously, you have to use this formula right here. But good news, mostly everything else stays the same. P is still my starting amount, so 8,000. My R, I have to convert to a decimal, so 0.029. 18 years, it's going to be my T. So 8,000 e to the 0.029 times 18. Type all that right into my calculator. So we get $13,483.16. Okay. And that is the review. Thank you for listening, and I hope you have a wonderful day.